part 2 video for 5-2 properties of exponents and radicals, and we're picking up with example 4. It says, what is the sum of the square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5? And this looks like a long, complicated problem, but really all you're doing is grouping the terms that have like indexes, simplifying your radicals in whatever way possible, and then combining any radicals together that have both the same index and the same radicand. That's the number inside of the radical. So I'm going to group the square root of 20 and the minus square root of 5 together. Then I'm going to group the minus cube root of 16 and the plus cube root of 250 together. And now I have to go through and rewrite these. So the square root of 20 is the square root of 4 times the square root of 5. The square root of 5 has no perfect square factors, so I can't simplify that at all. 16 has a perfect cube factor of 8. And then the leftover factor is the cube root of 2. 250 has a perfect cube factor of 125. And its leftover factor is also a 2. So this square root of 4 times the square root of 5 becomes 2 square roots of 5. Then I have minus the square root of 5. The cube root of 8 becomes a 2. So that's going to become 2 times the cube root of 2. The cube root of 125 is 5. So this is going to be plus 5. And then that other cube root of 2 also carries down. So now we can go through, if they have the same index and the same radicand, I can combine them together. I have 2 square roots of 5 minus 1 square root of 5, which is going to give me 1 square root of 5. Negative 2 cube roots of 2 plus 5 cube roots of 2 is going to leave me with 3 cube roots of 2. And that would be our correct answer. There's nothing else we can do with this. You can't combine square roots with cube roots. You do have to leave them both separate. I'm actually going to skip this part B. If you're interested in this example, it's in your textbook. This is not something I really want to focus on at this time. So that brings us to example 5. It says, what is the reduced radical form of each product? So we are going to be distributing and doing FOIL in part B, and then simplifying what we get as a result. So I'm going to distribute here. I have the cube root of 7 times 2 is going to be 2 cube roots of 7. The cube root of 7 times negative cube root of 49 is going to be minus the cube root of 343. Well, 7 has no perfect cube factor, so that's going to have to stay cube root of 7. 343 is a perfect cube, and the cube root of that is 7. So this is just going to be a minus 7 on the end of that term. For part B, we are doing FOIL, so we have to multiply the 2x's together. The 2x times the negative square root of 3, the negative square root of 3 times the 2x, and the negative square root of 3 times the negative square root of 3. 2x times 2x gives me 4x squared. 2x times negative square root of 3 is negative 2x square root of 3. Negative square root of 3 times 2x is negative 2x square root of 3. And then negative square root of 3 times negative square root of 3 is going to be a plus square root of 9. So I only have the one x squared term. My middle two terms, I can combine those together. They're both square roots of 3, and they're both negative 2x's. So that's going to be negative 4x square root of 3. And then the square root of 9 is just 3 with no radicals, so there's going to be a plus 3 on the end. And that's multiplying. Well, if we do multiplying, we're also going to have to do division. Division is very similar to how we reduced terms that had I in the denominator. You do have to multiply by the conjugate of whatever's in the denominator, which means you're going to multiply by, if there's two terms, like this one has 2 plus the square root of 5, we are going to multiply by 2 minus the square root of 5 on the top and on the bottom. So there's my original question. I can't have a radical in my denominator, so I do have to multiply. So I'm multiplying by a factor of 1, but this is going to make it so in the denominator, my radical should disappear. So on the top, I have 2 minus the square root of 5. On the bottom, 4 minus 2 square root of 5 plus 2 square root of 5 minus the square root of 25. The middle two terms add out. I have the 4 on the bottom. The square root of 25 is 5, and there's a minus in front of that, so it's a 4 minus 5 in the bottom, which is the same thing as negative 1. So this is really 2 minus the square root of 5, the whole thing divided by negative 1. So it's negative 2 plus the square root of 5. So that's how you would rewrite that to eliminate the radical in the denominator. There is a concept summary on page 252 in your textbook if you're interested in looking at that, just to kind of go over everything that was covered in 5-2. Please go back, rewatch the first video, rewatch this video, and reach out to me if you have any questions.